Hey everyone, today we are going to look at LeetCode problem number 334, increasing triplet subsequence. So in this question we have given a nums array and we need to find triplets such that nums of I is greater than nums of j is greater than nums of k and I is greater than j is greater than k. So so the first solutions that comes in our mind for this is the brute force approach, and the brute force solution will be. So the brute force approach will of course give time limit exceeding, and in this question what we are doing is we are just looping through. We have three variables I, j, and k, and you can see I is starting from 0 and j is I plus 1 and k is j plus 1, and here we are just comparing this condition if nums of I is greater than nums of j and nums of j is greater than nums of k, and if we have found that we'll just return true, otherwise we'll just return false. So of course it will give time limit exceeding and we can move forward to the other approach. So the another approach that we can use for this question is the longest increasing subsequence. So in the longest increasing subsequence, instead of having three triplets, we are finding the longest possible triplets, and the longest possible is in our result. So we will just do some modification, and in the modification, what we will do, we will just check if our DP variable is 3, which means that if whether we have found any triplet increasing by 3. So this will also give us time limit exceeding. There will be only one test case which will be failed for this one, and we have to optimize a better solution. So let's see the optimized approach. So the optimized solution for this will be we will be taking two variables left and mid, and for both we will be adding, and for both we will be giving them integer of maximum value. So or what we will do, if we have encounter a value which is greater than which is less than the left value, we will update our left variable. Similarly, if we will encounter any value which is greater than the mid, then we will update the mid value. And if we have found a value which is both greater than left and mid, so we will just return true. So let's try run this. We will be updating our left and mid values. So at first, we know that it is infinity, which is integer max. After that, after one have arrived, we this condition will be true, and left will be updated to 1. After that, we have 2. So now we can see that this condition will fail. So it will go in this condition and update mid to 2. And after that when we have arrived with 3, then this condition for all left and right, like the value is not greater than, so it will update, it will just return true. So we are just taking two values. Okay, so in this example, first of all, we'll have infinity, then we have 5, so we'll update it by 5. Again, we can see that 5 is greater than 4, so we'll update our left again, which will be 4 again. Again, we'll see that it is greater than our left is greater than this nums of I, so we'll again update, and it will keep on updating because all of the elements are in decreasing order. So let's see some more examples now. So first we'll have 2, so we'll update our left to 2. Then we have 1, which is less than, then this is 2 is greater than 1, so we'll update 1. Now we can see 5, uh, we can see this condition will fall because this condition will fail because 1 is not greater than equal to 5. So we'll move to this one, we'll update mid to 5. Then we have 0, so we'll update our left. Then we can see 5 is greater than this 4, so we'll update our mid to 4. Then we have 6, so now we can see 4 is greater than 4 is not greater than 6, so we'll go in this else loop and we'll update it, will return true. So this will be this So we'll follow this approach for this test case. Now, now you will be having some doubts with this, like how this approach is working. So let me give you one more example, which will make it more clear. So let's see one more test case. Then now we are having this 12. So we'll just update our left with 12. Then again, as 12 is greater than 11, we'll update 11. Now 11 is not greater than 15, so we'll update it 15. Now we are having this 2, so we'll update it our left to 2. Then we are having 16, and 16 is greater than 15, so we'll just return true. And you might be wondering, like right now we are having 2, 15, and 16, which is a triplet, but like the order we were expecting is not I greater than j greater than k. But like it's not like they are asking for the exact triplet they want. They were just asking whether the indices whether like such indices exist or not, and it exists because the possible solution here is 11, 15, and 16. But we have written 2, 15, and 16 because our algorithm is uh, designed in such a way that it will just keep on keeping the elements which is less in the left. So this approach won't be working if they will be asking us about the exact triplet which is satisfying the condition. But like uh, this will be our exact solution, but we have stored this. We have like given answer on this. So this will be the approach, and if I will submit this, it will be accepted and it is efficient also. Which so see you in the next video.